Hey guys, welcome back to Learn Python the Hard Way. In this exercise, we're going to learn about dictionaries as an additional data type that we can use apart from lists. So dictionaries are another data structure that we can use in Python, and dictionaries are abbreviated dict, D-I-C-T, and it's a way to store data comparable to how we used list before, but instead of using numbers to get the data, so for example the first index of our list or the last index of our list, we can use basically anything or almost anything to identify items in our dictionary. So let's have a quick look at what we can actually do with dictionaries. And let's open the terminal and feel free to follow along. I'm going to open the Python interpreter by typing in Python and then Python version in the console here. And first of all, we can define a regular list with different entries. So we have seen that before already. Here we have a list things with 4 different entries. And then we can go ahead and, for example, get the value at index 1. So since lists are 0 based, that would be b in this case, which we print out. And then we can go ahead and, for example, replace that value. So in this case here, we are replacing whatever is at index 1, which is b in this case, with the letter z. And then we can go ahead and print out what is now at index 1, which of course is a new letter we added. So there's nothing new here. That's basically how lists are working. However, dictionaries work a little different. So if we take a look at this example here, we can go ahead and define a new dictionary, which, different from lists, actually starts with curly braces here. And we can type in a key, for example, name, and a value, which can be the value of a person. And of course, we can add not only strings here as values, but also numbers, for example. Or we can even go ahead and, for example, do this here and do a multiplication. So do a computation here and add this for stuff. So if you take a look at that, now we can see stuff actually has those 3 key value pairs added in here. Name, so name z, age, which is set to 39, and height, which is 74, which is actually the result of doing this computation here. So similar as to how we did this with lists, we can go ahead and print out the value that we assigned, but other than with lists, we would not use the index or the number, but instead we would use basically the key that we defined. So in this case here, we defined the key name, and if we print this out now, we get the value that's associated with this key. And we can do the same, of course, with other keys. So for example, with the key age, then we get back 39. And finally, let's repeat the step with the value for height, and then we get back 74. So in all of these 3 cases, we basically referred to the key, and we got back the value that's associated with that particular key. And now to add additional values to our dictionary, we can go ahead, and what we need to do is we need to first of all define the key for the new key value pair that we are adding, so in this case city, and then we set it to the value. And now if we take a look at stuff again, we can see we have an additional key value pair added. In this case the key is city, and then the value is SF. And of course, similar to how we did this before, we can still print out what the value is for the key city, and of course we get back SF. So that's how we can use dictionaries in contrast to using lists. And we don't always have to use strings as keys. We have another example here where we're actually using different keys, so in this case just numbers, integers. So if we take a look at stuff that we defined before, we are just adding a new key value pair. In this case, the key is actually the number 1. and the value is a string. So we can add that, and if we take a look at our dictionary now, we can see that we now have a mix of different keys, which are mostly strings in this case, but here we also have a key that is a number. So we are not restricted to strings when we work with dictionaries. And of course, we can add another key value pair here, which again uses an integer and number as a key. And now let's print out the value for the key 1 in our stuff dictionary, and we get back wow, which we added before, and we can repeat, of course, the same steps for the key 2, which we set to this value here, and then of course that is being printed out. Alright, and then of course there are a number of different functions that we can use on our dictionaries. So for example, if you want to remove an entry from our dictionary, then we can use, for example, the pop function here. So if you take a look at stuff again, we have those values in our stuff dictionary. And now if we go ahead and we say pop, and we pass in city as a key, then we will basically pop off the value here for the key value pair where the key is city. So if we take a look at that, we get back SF, which is the value for the key city. And if we take a look again at stuff, we can now see that we actually removed the key value pair city and SF from our dictionary, so it's no longer displayed here. Now if we repeat those steps here for popping off the key value pair with the key 2, we get back the value here. And if we take another look at our dictionary, we can see that now indeed our key value pair here has been removed as well. So we're basically altering our dictionary and we're removing key value pairs. So let's take an example of a little bit of a longer program that we can work with. So let's open our terminal again. Let's quit the Python interpreter, and within our repository here, within our folder, we can create a new Python file. I'm using Visual Studio Code, so I'm typing in code followed by the name of the exercise. And let's confirm to create a new text file, to create a new Python file where we can work with a more extensive program here with dictionaries. So first of all, we're going to create a mapping of state to abbreviation. And we're going to have a couple of different states that we add in here, which is of course a dictionary where we have a key, for example, Oregon, and then a value, which is just the abbreviation. And we can add a couple of other states in here, for example, Florida, California. And we're always separating the key value pair with a colon, so that we identify what is the key, what is the value, and then we separate those key value pairs by comma, so that Python knows which are the different values that we're adding in here. Alright, so that's our states dictionary. Then next, we add another comment here, create a basic set of states and some cities in them. And then we have a new dictionary here called cities. Now we can go ahead and for each of the states basically add in a city. And the principle, of course, is exactly the same as we did before. We are adding the key value pairs in here and we're storing all of that in a dictionary. So let's add some more cities to our cities dictionary. So we're gonna add NY and set it to New York. And we're gonna add the key OR and set it to Portland. So next, let's print out some cities. So first of all, what we're going to do is we print a dash here 10 times. That's the first print statement. And then we print out New York State has. And now we can go ahead and take our cities dictionary and actually pass in the key NY to retrieve the value associated with it. And if we look back, we can see here we set the value for the key cities NY to New York, so that will be added in here. And let's repeat the same steps here for Oregon. And then after that we can print some states. So again, we start out by printing the dash character here 10 times just as a separator. And then we can continue with our statements here. So Michigan, or Michigan's abbreviation is, and then we pass in Michigan as a key, and we get back the value, of course. We can do the same for Florida. And by typing this out, of course, we get the hang of it pretty quickly. So we get more familiar with working with dictionaries. Do it by using the state, then cities dictionary. So again, we print out a dash here 10 times. And then we say Michigan has. And now we pass in cities. And now what we do is basically we nest those keys inside of each other. So we have here the states dictionary and we pass in Michigan. So that's basically here. The first dictionary we define, so when we pass in Michigan, we get back the value, which is MI, which automatically we're going to use as the key again for the cities dictionary. So here we have our cities, and if we pass in the key MI, we get back Detroit. So this is how we can basically nest different dictionaries, different keys inside of our dictionaries, and then retrieve the value ultimately here from the cities dictionary. And let's repeat the same step here for Florida. After that, we can print out every state abbreviation. Now we're using a for loop to iterate over that. And we're using printf to print out state is abbreviated like this. And just to see what's happening here is, of course, we first of all have our separation here using the print statement where we print out the dash character 10 times, and then we loop over state and abref, so those two variables here in our list. So what we do here is we take states, our states dictionary that we defined before, and we call the function items on it, and then we turn that into a list. And then basically we take the state and the abbreviation, so the key and the value basically, and print that out. So that's a shorthand form for basically turning our states dictionary here into a list, and then iterating over it to print out basically every state and then the abbreviation that's associated with it in our states dictionary. And we now do basically the same thing with our cities in each state. So again, let's start out by printing out the dash character here as a separator 10 times. And now we do basically the same step, but this time for the cities. So let's type that out here. Now we can do both at the same time, which we already saw an example of before. So here we again have a separator at the beginning, and now we say for state and abbreviation in states items. So we again start out with states.item, and we take a look at our states here. We basically go through each of the abbreviation in the states, and let me just take a look here because there seems to be an issue because this is highlighted in a different way. So I'm not quite sure what that was about, but now it should be adjusted. So we basically loop over our states here, and again we save the key and the value in state and abbreviation respectively. And now we go ahead and have actually two print statements. First of all, we're gonna print out the state. It's abbreviated, and then we pass in the abbreviation. And after that, we go ahead and type out it has the city, and now we take our cities dictionary here and we pass in the abbreviation. So basically what we got back from our initial states dictionary. And I may have to take a look at that a little bit later because there still seems to be some issue going on. Anyways, let's continue for now. We did that, and then we print out the dash 10 more times. Now we go ahead and call states get, and we call Texas. And that is basically a way to get an abbreviation by a state that might not be included in our dictionary. So if not state, print sorry no Texas, because that's not part of our dictionaries that we defined. And we can also get a city with a default value. So here we say city is equal to cities.get. And here Texas does not exist, it's not part of our list. Okay, let's save this and let's execute our code now. We're probably going to encounter some kind of issue, but let's take a look at that. No, actually it worked out properly, so maybe that was a mistake here by Visual Studio Code. We start out here with New York State. New York State has New York. Oregon State has Portland. Then Michigan's abbreviation is MI, and we basically print out all of that. And here at the end we see sorry no Texas, because that wasn't part of our dictionary. And then we also print out it does not exist, it's not part of it. So that's basically how we can use our dictionaries to print out the different keys and values and to work with it. So dictionaries, as we saw before, are another example of a data structure that we can use like lists to store data. And in contrast to lists, they are not, we don't just provide a value, or just add the index values to it, but instead we always add a key and a value, and then the key always maps to the respective value that we're working with. All right, and let's now take a look at some of the study drill questions here. So we could repeat the same step as we did before here with the different keys and values for another country, for example, or different states or cities, but the principle would basically be the same. A second study drill is to find the Python documentation for dictionaries and try to do even more things to dictionaries. So if you hop on over into the Python documentation, in the data structure section, we can find here on the left side that there are the documentation about dictionaries. And here we can see some examples of how we can work with it. So if we go back into our terminal, for example, and we switch over to the Python interpreter, we can, for example, go ahead and define a dictionary here with a couple of values. So let's just add some keys and some values. And let's save that. So of course we can print out our dictionary. We can get back the value by typing in the key, parentheses, but we can also go ahead and, for example, delete a value. So we could, for example, say we type in del for delete and then type in dictionary, and for example we want to maybe remove the h. So we confirm, and if we type dict in again, we can now see that the second key value pair h has been, so h and the value 22 has been removed because we executed del on it. So that's one additional function, for example, that we didn't use before yet. So next, find out what you can't do with dictionaries. So one big thing that we basically can't do is keep order. So lists are always sorted in a certain way, and we use our index to basically reference the respective value in our dictionary, in our list. Dictionaries are not sorted in that way, so they always map the key value pair. And that means the order doesn't really matter. So it doesn't really matter that first and name is the first key value pair and h and 22 the second one. We always use the key to refer to it. So therefore the order doesn't matter and basically isn't kept. So if order is really important, then it might be better to use a list instead of a dictionary. So what is the difference between a list and a dictionary? So a list is an ordered list of items. A dictionary, or dict, is for matching some items, keys, to other items, the values. So that's basically what it comes down to. If we have a sorted list of values, we would use a list. If instead we basically don't care about the order, but we just want to make sure that we have the right keys and values, then we would use dictionaries instead. So what would we use dictionaries for? So when we have to take one value and look up another value, then we would use a dictionary. So we could call dictionaries lookup tables that we always reference the key basically to get the value. So what would you use a list for? So if you want to, we would use a list instead of a dictionary if we have any sequence of things that need to be in order, because dictionaries again are basically not ordered. And here, if we only need to look something up by a numeric index, then we would use lists rather than dictionaries. What if we need a dictionary, but it needs to be in order? So there's actually a separate type here, collections.orderedDict, which is a separate data structure in Python. So we could use that if we want to use a dictionary that should still be in order. So that's it for dictionaries and for exercise 39, and see you guys in the next video with the next exercise.